Assalamualaikum and hi! For today's video, we will discuss on our assignment, which is number 13. Before we start, let me introduce ourselves first. Our group consists of 3 members. The first one is No Ayuni Liana, the second member is Mirza Husna, and the last one is me. My name is Siti Zul'Aleesya. And without wasting any time, let me proceed to our discussion. Let's go! To answer question number 13, we have to look at the mass spectrum first. So, at the mass spectrum, it shows the heaviest peak at 150 and it corresponds to the intact molecule with the molecular weight of 150 gram per mole. So, this suggests the compound could have a molecular weight of 150. However, the exact identity is not confirmed yet. The base peak, which is the tallest peak, is at 135 and it is the most intense and indicates the loss of methyl group CH3 from the methoxy group OCH3, a common fermentation pattern for compounds containing methoxy groups. Furthermore, a peak at 77 represents a benzene ring fragment, which is typical of aromatic compounds. So based on the molecular weight and the fermentation pattern, this can be hypothesized that the compound is 4-methoxyacetophenone. However, other compounds with similar structure and mass could also be considered. So, to further confirm this assumption, we need to analyze further on FTIR and NMR spectrum, and it can show the characteristic functional group absorption such as the carbonyl trash and the methoxy group vibration that can help to verify the presence of the specific functional group.
Now, I will explain on how can we figure out about the structure that we want to find through IR spectrum. In this spectrum, firstly, we need to analyze the key peaks, which is the one that is strong and distinctive. From here, in the range of 1200 to 1000 cm inverse, the methoxy group, which is OCH3, contributes a C single bond O stretching absorption. Next, let's see another strong peak, which is in the range of 1700 cm inverse. At this range, we can figure out that there is carbonyl group in the structure where there is C double bond O stretching vibration happen. The last one is the CH stretching of the aromatic rings appears around 3100 to 3000 cm inverse. So, to conclude in this spectrum, we found out there are 3 different functional groups in the structure, which is aromatic ring, carbonyl group, and lastly, methoxy group.
Okay, for the proton NMR analysis, we can see for the aromatic proton, this typically appear as a multipler in the 7 to 8 region, indicate the presence of a benzene ring or similar aromatic structure. Second, about methoxy group, appear as a single around 3.8 ppm, significant a single set of equivalent proton in the methoxy group. The last is about methyl group adjacent to carbonyl, appear as a singlet around 2.5 ppm, indicate a methyl proton are near the electron withdrawing carbonyl group. Okay, for this spectrum, carbon 30 NMR analysis, we can see first is about carbonyl group. This show a distinct signal around 190 to 220 ppm corresponding to carbon in carbonyl environment. Second, about aromatic carbon, appear as a signal between 100 to 160 ppm, indicate carbon in aromatic ring. The last is about methoxy and methyl carbon. The methoxy carbon resonate around 55 ppm, while the methyl carbon resonate around 20 to 30 ppm, both in their respective chemical environment. Okay, for the last part is we can see from the proton and NMR spectrum analysis, we get at the 2.5 ppm, we get the matic group. For the 3.9 ppm, we get the metoxic group singlet, and for the 7 to 8 ppm, we get the aromatic ring doublet. And then for the mass spectrum analysis, we get the molecular formula, and based on molecular formula, we can calculate the DBE, double bond equivalent. Then we get 5. This indicates the present 5 degree of unsaturation, double bond, ring, or aromaticity. Then for the FTIR spectrum analysis, we get the spectrum confirm the presence of carbonic group characteristic of ester. Then the purpose of structure, based on the NMR, mass, and FTIR data, the compound is like this.
That's all from us. Thank you for watching.